Okay, today we're going to be simplifying rational expressions. It's important to remember that a ratio is a fraction in the form of a over b, where a is the numerator, b is the denominator. And since b is the denominator, b cannot equal 0. So let's talk about excluded values. Excluded means things that have to be left out. And an excluded value is anything that makes your denominator 0. Okay, so we want to find out, let's say we have an expression of 4 over x. Well, any excluded value in that situation, we want to take it out. So in this situation, our excluded value would be x equals 0. Okay, in another situation, another possible situation, let's say we have the rational expression of 1 over x minus 4. This is a rational expression because you have a ratio or a fraction with a numerator and a denominator. We would want to identify any excluded values by saying, okay, what value of x would make our denominator 0? Well, let's start by just pulling out that denominator and setting it equal to 0. And then solving that equation for x. So we're going to add 4 to both sides. And we get x equals 4. So x equals 4 is the excluded value for this situation. Now you might run across a situation where you have a denominator that might be, I don't know, a polynomial. Let's say you have k plus 1 over k squared minus 4k minus 5. Okay, so here you have a polynomial. And you again want to identify, okay, what is going to make my denominator 0? So before you can identify that, you have to factor this polynomial. So you're going to open up your two sets of parentheses. Big X, coefficient of 1 times negative 5 is negative 5. And then we put the negative 4 on the bottom. So what can we multiply to get negative 5, but add to get negative 4? Well, that would be negative 5 and positive 1. So we have k minus 5 and k plus 1. Now, since we have two binomials here, we're trying to identify what our excluded values are. So we're going to set this equal to 0. And here's where we're going to apply what we learned about solving quadratics, and we're going to use the zero product property. So because k minus 5 times k plus 1 is equal to 0, then k minus 5 is equal to 0, and k plus 1 is equal to 0. Solving both of them for k cannot equal 5 in this situation. So this will be an excluded value. And we'll subtract 1 from both sides here. And in this case, k can also not equal negative 1. So our excluded values for this situation here is k cannot equal 5 and k cannot equal negative 1. Okay, let's talk about actually simplifying rational expressions. Let's start with a simple fraction that we all know how to do. Let's do 2 over 4. Well, we all know how to simplify that rational expression, which it technically is rational because it's a fraction of a over b, and b does not equal 0. What do? Well, we're essentially going to divide top and bottom by the same number, or we could look at it like this. 2 over, and then 4 is technically 2 times 2. Notice that a 2 at the top and a 2 at the bottom. Well, 2 divided by 2 is 1. So you could cross those out. And you get a 1 at the top. And you're left with a 2 on the bottom. So we all know how to do that. Well, let's say we've got an expression of 3t cubed over 12t. And we want to simplify that. Well, I'm going to apply the same concept here. I broke this down into prime factors, so I'm going to do the same here. 3 is already prime, so I leave that alone. I'm going to break up t cubed and make it 3t's. And then I'm going to find prime factors of 12. Well, I know 2 times 2 is 4, times 3 is 12, and then I have 1t. So like I did up here where I crossed out the numerator and denominator that made 1, I'm going to do the same here. I have a 3 and a 3, and a t and a t. And nothing else similar top and bottom. So I'm going to take everything together and multiply it back together. On top I have 2t's, which is t squared. And on the bottom I have 2 times 2, which is 4. So there's my simplified expression. Okay? If I were asked to identify an excluded value here, my excluded value would be 0. Okay, let's take another situation where we might have not 2 monomials, but maybe polynomials involved with our simplification. Let's take that expression that we used previously, k plus 1, over k squared minus 4k minus 5. And let's work on factoring. We want to simplify the numerator and simplify the denominator by factoring, and then we can talk about canceling things out. K plus 1 is already simplified, so I'm going to leave that alone. And I'm going to factor the trinomial on the bottom, which we already did previously, so I'll just bring it back over here. It was k minus 5 times k plus 1. And instead of looking for single terms that we can cross out, you'll notice that we have common binomial factors. K plus 1 divided by k plus 1 is similar to 2 divided by 2. They're both 1. So this cancels out and this cancels out. Nothing else that's similar that we can cancel out, so we bring everything back together. And if we have nothing on top in our numerator, then that's that invisible 1. And then on the denominator, we have k minus 5. And our excluded value in this particular situation is whatever makes our denominator 0. So our excluded value is k cannot equal 5. All right, let's try another one. Y squared minus 16 over y squared minus 8y plus 16. We're going to simplify both top and bottom. This time, I notice that my numerator is a difference of squares. So I'm going to make that my y plus 4 times y minus 4.